Okay, I hope you've had a chance then to really go through that and basically verify that you get the same reduced equations that I'm showing you right here. Okay, so now we want to actually implement the logic for this, and look, lots of different ways of doing that. What I'm going to show you here is, let me just draw for a moment a piece of wire. Really, that's all it is. I'm going to say that that basically would be A, and so I need to basically control the logic levels on that piece of wire, which is A. Maybe I'm going to call this one B, and maybe I'm going to call this one over here, I'm going to call that C, all right? And then we'll use this to implement the logic, all right? So let's look at this. What is this guy, X1? Well, it's really the exclusive OR, isn't it? We said that before, of B and C. So here I go. I'll just show you an exclusive OR gate sitting here like this. That would, of course, be X1, and what am I doing? I'm taking B, feeding in, and I'm taking C, and I'm feeding in. All right? What is X2? Well, X2 is just C, so I'm just going to grab the C here, like this, and that, of course, is really X2. Okay? Well, what about X3? Well, let's look at X3. That's A bar. No, I'm sorry, that's A, B bar. All right, let's put that in. Okay, it's an AND operation. So here I go with the AND operation here. And what am I looking at? Taking an A, feeding in the A, and then of course I've got B bar. So here's B. Look, I'll bubble that sitting there. So I've got B bar going into the AND gate, and of course that represents X3. And then finally I've got this AND OR combination over here. So really, let me show you that. Here is an AND gate. What am I looking coming in? I'm looking at coming in A bar, so I'll bubble there. I've got what? B bar, so I come in, bubble before the gate, and then of course I've got C bar, once again bubble before the gate. So that's my first product term. My next product term sitting here would be what? AB. So I'm going to grab A, feed it into the AND gate, going to grab B into the AND gate, and then I've got a C bar. So here I go, before going into the gate, I invert or bubble, and that's my second product term. And really what I want to do now is just OR these two terms together, and of course that is going to give me X4. All right, so that is X4. All right, now, once again, I'm looking at it, and that's the A input. Of course, that really is the B input, and of course that over there is the C input. Okay? And so therefore now what we have really is the actual logic implementation. I want you to make sure that you really understand that, and you're able to go through really that complete exercise. Okay? Look, let's now just address a couple of points in relation perhaps to the lab, and this might be the first digital lab, for example, okay? Now, so we'll say that these are some lab issues, okay? It could be, well, how do you provide, for example, those ABC values that we said? You might want to provide logic level 0. You might be able to want to provide a logic level 1, or how do you do that, okay? So basically what we're going to do is we're going to use a switch for that, okay? This could be one of your dip switches, for example, or it could be a single switch, okay? There's the switch. That's what the switch looks like. We're going to tie one side of the switch through a resistor, could be a 1K resistor, to 5 volts, and then the other side of the switch we're going to simply tie to ground. Now, that then provides our input then to the logic. So that would be the input to the actual logic, could be the input to an AND gate, whatever it is, okay? All right, when that switch is open, what is this voltage sitting here? Okay, what is that voltage? Well, look, is there any current? Well, might be if it's attached to a gate, but it's very, very small. Okay, so there's really no drop across that resistor, and so basically this voltage here would be 5 volts. In other words, we're pulling up to 5 volts because there's no current going through that resistor. So when the switch is open, okay, basically that produces logic level 1. What about when you close the switch? When the switch is closed, okay, what happens then? I close that switch. What's this voltage here? Well, it's a direct connection to ground, and so that corresponds to what? To really logic level 0. Okay, so you can use switches in this manner to provide then, let's say, like in the previous example, your ABC values. Okay? All right. Another point I want to make here is outputs, maybe driving an LED. Okay, so imagine that I've got some output here, okay, and I want to basically show that output by way of turning on an LED. Now, the first comment I want to make is that the TTL, which you're using, okay, sinks current better than it supplies current. So the arrangement that you might use would be this, where you have your LED, don't forget the current limiting resistor. This is tied to 5 volts, and the output's connected like so. Now, the only thing with this, of course, is that basically a logic level 0, is going to turn the LED on. Okay, so the LED turns on with a 0, okay, not a 1 when you configure in this case. And the current is actually, sinking through the gate rather than the gate having to actually supply that current. This is then referred to as a low acting output. In other words, the action is occurring on a low, and the action in this case is turning on the LED. That action is occurring on a low rather than a 1. Okay, and so that's important that you really understand that. And so this would be what we call a low acting output in this case. All right. Now, just going back to what we'd implemented before, we now know how to provide A, B, and C with perhaps 3 switches. Now, we might, in the truth table, have defined these outputs to be high-acting outputs. In other words, when there's a 1 here, you want to turn on the LED. Now, often it's nice to think about outputs as high-acting. If you've done that, and especially in the case of traffic lights and things like that, if you've done that and you've developed a logic, and these are high-acting signals, and you wanted to basically implement the scheme I just showed you, in other words, a low turning on the LED, how would you fix that? How could you easily fix that? Yeah, well, could you not put an inverter here, inverter here, inverter here? Okay, in other words, that would then produce a low acting output signal. So in a sense, it's like putting a bubble here, which would make that what? It would make that an exclusive NOR. If I put a bubble here, it basically makes that a NAND gate. And if I put a bubble here, that basically makes this thing over here a NOR gate. Okay? So it's very simple, really, to deal with that issue.